Okay, finishing up section 9.3 today. So this is 9.3, day 3. Again, still integration by parts, another trick today. And back to volume again at the end of the note. Okay, here we go. So right into examples. We've got the integral of sine squared 3x dx. Okay, we don't have anything that integrates to sine squared, so we've got to pick a u and a dv. And again, it's trial and error until you get used to doing these. And I'll just tell you, there's several ways you could break it up. Well, you can't let the sine squared be this because that's not integrable. So you could put the sine squared here, and then just the dx over here. Or you can break it up and think of it as sine x times sine x. And that is the trick we'll go with. So we're going to let sine 3x be here, and sine 3x dx be here. Because the sine squared, remember, is the sine 3x times the sine 3x times the dx. So I'm breaking the sine squared up. And if we go through our process, we do derivative here. So derivative of sine is cosine times the derivative of the angle. And if I integrate here, again, do everything in your head if you can. You need the derivative of the angle next to the dx. So we need a 1/3. And cosine's derivative is negative sine. So this is a negative cosine. So it will be a negative 1/3 cosine 3x. Okay, and this is never going to get to 0. So again, our trick so far to date was to keep integrating this until the original reappears. So let's bring sine back. So that means we're going to go one more time here. So if I integrate, I need the 3 here and another 1/3 here. I'm not going to write it down, so when I do my cross products, I don't include that, but I'm going to keep it in my head. So there's a 1/3 here times the negative 1/3 here. I'll have a negative 1/9 sine 3x. Okay, derivative here. I'll have derivative of cosine is negative sine, so negative. Derivative of the angle is a 3 times the 3 I had is going to give me a negative 9. Okay, so it's multiply, multiply, integrate. So plus, minus, plus. So writing this down, the integral of sine squared 3x dx using integration by parts is equal to this cross, which is going to be a negative 1/3 sine 3x sine cosine 3x. The next one, multiplying negative times the negative, 3 times the 1/9. We're going to have a positive 1/3 sine 3x cosine 3x. And then integrating, we'll have to be a plus, and the minus is plus the integral of, that'll go to 1 sine squared 3x dx. Okay, well, if I take a look at this, I've got a negative 1/3 sine 3x cosine 3x plus a 1/3 sine 3x. Those cancel out, I get 0. If I bring this back over, I'll be subtracting sine squared 3x from that. I'll have 0 equals 0. Which is true, which means I did all the work right, but this didn't get the integral for me. So there's another trick we need to do here. And the trick is to stop this thing one step earlier. So we're going to back up. It'll be this integral, this product, and then we're going to go across with this integral. So let's start it again. The integral of sine squared 3x dx equals, this will be a negative 1/3 sine 3x cosine 3x. And a negative and a negative is a positive. That'll go to 1 cosine squared 3x dx. Okay, I still have something I can't integrate, but if we use trig properties, I can rewrite this and introduce the sine squared back using our Pythagorean identity. Because remember, cosine squared equals 1 minus sine squared. So I am going to choose to rewrite this function in here as 1 minus sine squared 3x dx. And I'm going to break that apart into two separate integrals. 1 dx minus the integral of sine squared 3x dx. Now I've got a like term that I can add to the other side and not cancel it out. So I did make the original reappear, but with a trig identity instead. So if everything falls out, and you don't know till you try, then you got to come back and find another trick. And the more we work, the more tricks you get. So just doing some algebra, I'm going to add this integral to both sides. Adding the integral here. So now think of this as 1 times the integral of sine squared 3x plus another one. So I'm getting 2 of these integrals. So 2 times the integral of sine squared 3x dx equals, I've got this, negative 1/3 sine 3x cosine 3x plus the integral of 1 is x. That's gone. So now all I've got to do is divide 2 or multiply through by a half. So my final answer, if I multiply through by a half, I'll have a negative 1/6 sine 3x cosine 3x plus 1/2 x plus c. Okay, another trick is using trig identities to make the original function reappear. Okay, the next one. Number 2, the integral of the natural log of x dx. Okay, we've never been able to integrate this until today. So we're going to go with u and dv. So I'm going to I can't do the integral of natural log of x, so you know that can't go there. So the natural log of x has to go here. The 1 dx has to go here. And again, you don't have to write the dx. Okay, derivative here is 1 over x. Integrating here is x. I'm going to stop right there. Multiply. Integrate. I could have reassociated, but that's all right. Same thing. So the integral of natural log of x is x times natural log of x minus the integral of, when I multiply these together, I get 1 dx, integrating x, natural log of x, minus x, plus c. And you can add this to your blue sheet. Or I thought we were all done, but I forgot about this natural log business. Otherwise, you just have to do this every single time natural log comes up. So, on your blue sheet, somewhere in the integration rules, down on the bottom, if you can squeeze it in somewhere, the integral of natural log of x dx equals x natural log of x minus x plus c. Okay, we're going to be using this in the next problem. Number 3, the integral of log base 6 x dx. Okay, we have no integration rules for logs except for the natural log that we just did. So what we're going to do is use that change of base property to rewrite this. Change of base, log base a of x is log x over log base a. And we can make this log anything we want, and our goal is going to be natural log, so we know how to integrate that. So it's going to be natural log of x over natural log of a. So applying that to this problem, this becomes the integral of natural log of x over natural log of 6 dx. Remember, natural log of 6 is a constant. I'm going to pull 1 over, if I can break this up, 1 over natural log of 6 out in front of the integral. 1 over natural log of 6, and then natural log of x dx. At this point, you could use your UDV if you wanted with natural log, or you can use your blue sheet since we just did it. This 1 over natural log of 6 is just going to carry along. So it's 1 over natural log of 6. And then this integration rule is, right from your blue sheet, x, natural log of x, minus x, plus c. Okay, our last one of the day. I would like you to find the volume generated by revolving the bound region in quadrant 1 by y equals x squared e to the 0.4x and x equals 2 around the x-axis. Okay, graphing this. Let's see if I still have that in here. Y equals x e to the 0.4x. Oops, right there. I only want the part in quadrant 1, so I can see it's coming through the origin and then swooping up. And then I've got the line x equals 1, so it's going to be this little triangular region down here. I'm going to exaggerate it a little bit. So I know it's coming through like this, and I've got a vertical line at 1. Okay, and I'm revolving around the x-axis. So at this point, I can draw my rectangles up and down without a problem because it's consistent all the way through, or I can draw them left and right because it's consistent. I'm going to go up and down. So now my rectangle is perpendicular to my axis. That makes it either a washer or a cylinder. Because it's touching my axis, I've got the cylinder. So I'm going to use that cylinder formula from chapter 8. So, and I will need this intersection. Well, I guess I don't. I need the x value, and I know it's 1. So it's going from 0 to 1 on the x, because this is a dx. So I want to see all x's. So I guess shell would have been kind of tough, because I would have had to solve this for x, and I don't even know that we could have. So I don't think we had an option here but to make this vertical. So the volume now is the integral from 0 to 1. The cylinder formula, remember, is pi r squared h. The radius is from my axis up each time, so that's the function. So it's pi times x squared e to the 0.4x, and the width is dx, or the height, I should say. And so now, when I look at in the last chapter, we would have used function integrate here, but now we actually can do